Alright, boys and girls, today I'm going to go through the bump and the compensation strategies. Now these are two strategies that you could use for some addition and subtraction problems, but you have to decide when you think that they should be implemented, because not all times these strategies are the most efficient. However, when they are useful, they can actually be really an easy way of solving some of the problems. So that's what we're going to go through today. So the first one we're going to go through is the bump strategy. Now the bump strategy I would suggest you use mainly when you're doing addition problems, okay? And what we would try to do is we would use this strategy when one of the numbers that we use is close to a whole number, a round number that we think would be easy to solve with. So if we have 395 plus 88. Now you can decide that you think that the 88 is close to 100 and that's a really good number, or you could decide that 395 is really close to 400. So if we can just get that, a few more extra numbers to get it to 400, that actually will be quite easy to solve. Now I'm going to decide with this one that I think that 395 is the number that I'm going to try to bump up. So by bumping it up, that's why it's called the bump strategy. By bumping that up to the 400, what do we have to do? Well, we have to bump it up by 5. So we have to get an extra 5 numbers onto here. Now, the reason we call it bump is because we're bumping it up from one side, but whatever we use on one side to add on the other side, we have to take away from the other side. So if we're plussing 5 on this side, we need to take 5 away. Okay? So then this one should now be 395, it should be now 400, and the 88 take away 5, so the 8 take away 5 is 3. So now it is 400 plus 83, which is a really simple number now, which you don't have to do any algorithm for, and it becomes 483. Now you might say, Mr. West, if I'd just done it straight underneath each other and done 395 plus 88, I could have solved it a lot quicker than that, and it wouldn't have taken as much effort in my head. And that's true. However, if you're strengthening your brain at doing the mental strategies, you should actually be able to do this quite quickly. The way you're adding those and bumping those up in your head and adding and just dragging another 5 from the 8 across to here, you can do that quite mentally, and it becomes quite quick at doing it. So let's give it another go. So what we're going to do this time is we're going to solve, let's try a harder one. So it might be 5988 plus 4,125. Bit of a tricky one, okay? So we can see clearly here, this question looks a bit tricky, and it doesn't necessarily scream out that bump strategy is what strategy you could use. But if you have a quick look across, you can see that, you could probably take that down another 25 if you wanted to, or up to at 75 to get closest. But really it's this number here that's screaming out to me that this one could be used as a possible bump strategy one. So I can quickly identify that 88 means that it's only 12 numbers away, 12 away from being 6,000. So if I just want to borrow that from the other number, I could add another 12 here and then just take 12 away from this side. Now, if I'm adding 12 here now, my answer is 6,000. And if I'm doing 25, take away 12, now I can quickly do that in my head and realize it's 13. And so I realize that I've got 4,113 left. So now it's pretty easy here, because now I know that 4,000 plus 6,000 is 10,000. So the answer would be 10,113. Now I probably did oversimplify that a little bit and make it seem a little bit easier than what it actually was. However, I'm kind of then, once I'm using bump strategy, I'm kind of using split strategy in my head. I'm kind of going 6,000 plus 4,000, and then I'm just adding the 100, the 10 and the 3 after that to make it, 6,000 plus 4,000 is 10,000, and then it's just 10,113. So I know I made that look quite easy, but if you start getting used to this in your head, you should start to find it quite easy. Let's go through one more, and this time when I write it, I'm going to get you to try to pause the video and see if you can do this one by yourself. Okay, so the question I'm going to give you this time is 4,995 plus 3,263. Okay, so I'm going to ask you to pause it right here. See if you can give it a go yourself. Sorry, let's make that easier. Let's make that an 8. sorry, 4,995 plus 3,268. So I'm going to get you to pause it now. Okay, so now that you've paused and you had a go at the question, let's see how you went at it. So automatically my brain straight away has a look at this number and sees that that number is the number we're going to try to bump it up to. So we're going to try to bump that up to 5,000, and I can see that I only need a couple more to go. I only need an extra 5 here to get to that. So I'm just going to take 5 away from here, which means that my new answer would be 5,000 on this side, and the other side is 3,260, and 8 take away 5 is 3. All right, so now it should be pretty easy now with the extra 5,000 just in the thousands column, that it just becomes 8,263. You can see clearly here that if I was just doing it mentally, all I would just be doing is I would just be going, okay, so just bring a 5 across here, 5,000, and you could just add the 5,000 there. You don't have to be able to write this down to do this strategy. Hopefully you should get so used to it that you can do it in your head. Okay, so that's the addition one, but I'll show you that doesn't work if I was doing a subtraction problem. Let's say if you had 9 take away 4. Okay, I'm going to use that as an example just because I realize that I need a simple way to show you that this doesn't work for subtraction. If I'm like, oh, I want to bump this up to 10 to make this easier, so I'll just plus 1 on this side and then take 1 away on this side, then suddenly you've got a 10 take away 3, because you've plus 1 to make that 10 and you've taken 1 away to make 3. And suddenly then you've got the answer is 7. But we all know that 9 take away 4 is actually 5. So the question would be, what do we do if we want to use a subtraction? Well, that's where we get to the compensation strategy. So when you're doing subtraction, the slight difference that you would use is when you're doing subtraction problems, you only... Sorry, let me just write it out first. Okay, so let's say, it's a bad example actually, let me rub that out for a second. Let me write 128. Okay, great. All right, so with the compensation strategy, what you do is you add the same amount to both sides. So if you realize here that 997, you need to get to 1,000, you need to plus 3, then you plus 3 to the other side as well. So with subtraction, you plus or minus the same thing to both sides. Okay, so I plus 3 here, so that's now 1,000, and I've plus 3 here, so it's 131. Okay, so now, I mean, it might not be easy for you. You might need to do that. I personally wouldn't need to do that because I could just do, in my head, I would be doing 1,000, take away 100, which is 900. And then 900 take away 30, which is 870, and then take away the 1, which is 869. Now, I'm doing that in my head to make it easier. I mean, all I'm trying to get you to do is start being more flexible with the way that you solve number problems rather than just always referring back to that algorithm one. So I'll show you that again. So like I said, with subtraction, whatever you do to one side... So if I do something to one side, I have to do it to the other side. So if you had, so let's say 3,423 take away 996, okay? See that, if I saw that, I would be thinking straight away, oh, maybe you have to do algorithm, just write it underneath and just make sure you do it really easy. But if you didn't want to do it with using algorithm, what you would say is, one of these numbers actually is really close to 1,000, so all I need to do is add another 4. But the difference, like I said, between subtraction and addition is if I add 4 here, I have to add 4 on the other side as well. Okay, so now this becomes 1,000, and the other side, if I've added 4, becomes 3,427. Sorry, I said 77, I meant 27. Okay, so now look how easy that is. 3,427 take away 1,000 is 3,427. So I didn't actually really have to do that much more, okay, to solve that problem. So with addition, if you're adding on one side, you subtract the other side. But with subtraction, you just add to both sides. All right, so I'm going to give you one question here to try and see if you can do it without my help. So 727 take away 389. All right, I'm going to get you to pause it now and see which one of these numbers you think you could add to make it easier for you to solve this. And remember, if you add to this side, you need to add the same amount to the other side. Okay, so pause it now. Okay, so hopefully you've had enough time there to really look through and figure it out. So I can see with this side, this would be the one I think would be easier. So to get 389 up to 400, I'm just going to add 11 here. So now that's 400. Now if I've added 11 here, if I add 11 on this side, 11 on this side, I need to add 11 on this side. So that becomes 738. Now 738 take away 400 is really quick for me, because 700 take away 400, the answer would be 338. Okay? Like I said, you could easily just write 727 take away 389 and do it your old-fashioned algorithm way. But I really want you to try to get better at strengthening your ability to solve number problems in your head. So this is a strategy that I would use. So if you want to have a look at the difference between both of them, bump and compensation. With bump strategy, what I would do if I wanted to add 1 to this side, because I'm borrowing from this side, I have to take 1 away. So it becomes 300, take away, 194. With compensation strategy, if I'm using subtraction questions, I'm doing 395, take away 199. If I add 1 to this side, then I add 1 to that side as well. So it'd be 396, take away 200, which would equal 196. Okay, I hope that's made it easier for you. Remember, I really appreciate feedback from the video. So if you have any suggestions or things that you liked about the video, please make sure you tell me so I can make them improve for next time. All right, thank you.